In this video, we are going to go over lesson 7.2, representing a function part 2. This is the real world application. Okay, so our objective is I will represent a function as an equation, table of values, set of ordered pairs, and graph. Okay, we're going to represent the same equation in 4 different ways, and this is going to apply to the real world. Okay, our essential question, as usual, goes along with our objective. In what ways can you represent a function? Okay, and I'm going to show you them with our real-world example. So the real-world example says, suppose a car gets 28 miles per gallon. In this situation, distance is a function of the number of gallons of gasoline. Represent this function in 4 different ways. Okay, and here, just like our objective, we have the rule, which is the equation, the table of values, the set of ordered pairs, and then on the back we're going to do the graph. Okay, so let's look back at our example. Remember, when we deal with functions, we need to figure out what the input, which is the x, and the output, which is the y, represent. Okay, remember, you have an input and an output when we're dealing with a function. And the easiest way to figure out in a real-world problem what your input variable is and what your output variable is when we have our rate miles per gallon, it's the output per the input. Okay, so the output would be the distance in miles per the input is going to represent the number of gallons of gasoline. Okay, another way to look at it is it says in this situation, distance is a function of the number of gallons of gasoline. It's always that the output is a function of the input, which in this case is the number of gallons of gasoline. Okay, because the output depends on the input. All right, so let's label x as your input, which we said is the number of gallons of gasoline. And then your output is the distance in miles. Okay, so let's look at the equation first. Suppose a car gets 28 miles per gallon. That means if the y represents the distance in miles, y, meaning the distance in miles, equals 28 times x, the number of gallons. So y equals 28x. Okay, you can see that this is a linear equation because it's in the form y equals mx plus b. M is 28, that's your slope, and b is 0. This is going to be a line that when we graph it goes through the origin. Okay, after we get the equation, okay, since y is a function of x, it's going to be y equals 28 times x. Next, we have to get our table of values. We're going to represent this function as a table of values. Okay, we'll get 4 different ordered pairs so that we can have a nice line when we graph it. And we know that the X, we said the input represents the number of gallons of gasoline. And then the Y, which is your output, represents the distance in miles. Okay, so this is your X column, this is your Y column. Okay, now we have to figure out how we're going to fill in the table of values. It would make sense that if we're talking about gallons of gasoline in the car, let's do 1 gallon, 2 gallon, 3 gallon, 4 gallon. Okay, obviously we're not going to have negative gallons, so we're not going to have negative numbers. So we'll start with that. So we have our X value, meaning the number of gallons of gasoline. Is 1, 2, 3, and 4. Now we have to figure out what is going to be the distance in miles, your Y value, when X equals 1, 2, 3, and 4. So here we can use our equation. We can go back to the equation, and we want to plug in each X to get what our Y value is. So let's start with 1. When X equals 1, we're going to go over to our equation and plug it in. Y equals 28 times 1, which equals 28. So when the gasoline, the number of gallons is 1, you can travel 28 miles, right? Because it's 28 miles per gallon. And then we have to figure out when the number of gallons of gasoline is 2. Let's go back to our equation. It would be Y equals 28 times 2, right? Because we have to plug in 2 for X, which equals 56. So after you've used up 2 gallons of gasoline, you could have traveled 56 miles. Okay, for every 2 gallons of gasoline, you can travel 56 miles. Then we have to figure out, after 3 gallons of gasoline, what could be the distance. Let's plug in Y equals 28 times 3, because this time we're plugging in 3 for X. Okay, and that equals 84. Let's put it in our table. And then 4 gallons of gasoline. We have to plug in 4 for X. So it's going to be Y equals 28 times 4. Which equals 112. Okay, so 4 gallons of gasoline will get you 112 miles in distance. All right, now an easy thing that we can do is represent the function as a set of ordered pairs, especially after we have the table of values, because the table of values correlate with the set of ordered pairs. The first set, to represent 1 gallon of gas and you traveling 28 miles in distance, it would be 1, 28. 2 gallons gives you 56 miles. 3 gallons gives you 84 miles. And then 4 gallons gives you 112 miles. Okay, so we just got the set of ordered pairs. Remember, the objective is we're going to represent a function, right? The same function as an equation, table of values, set of ordered pairs, and a graph. So we just showed the same function represented by this real-world situation as an equation, a set of ordered pairs, a table of values, and a set of ordered pairs. So the last thing we have to do is graph these set of ordered pairs to represent our function. Okay, and that is going to be in the next video, part 2 of example 1. So go ahead and watch that to show you how to graph the set of ordered pairs correctly and represent the function.